स्टूडेंट ऑर्गेनिक केमिस्ट्री के एक और शानदार क्लास में आप सभी का वेलकम। आज का टॉपिक है आइसोमेरिज्म इन ऑर्गेनिक कंपाउंड। सबसे पहले ये समझते हैं कि व्हाट इज़ द मीनिंग ऑफ आइसोमेरिज्म इन ऑर्गेनिक कंपाउंड। द ऑर्गेनिक कंपाउंड्स हैविंग similar molecular formula but having different physical and chemical properties are known as isomers, and the property is known as isomerism. And the isomerism further classified into two main categories. The first one is structural isomerism and second one is stereoisomerism. Structural isomerism further classified into six different categories: chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism, and the last one, ring chain isomerism. On the other side, stereoisomerism further classified into two categories: geometrical and optical isomerism. Now let us try to understand what is the meaning of structural isomerism. The organic compounds having similar molecular formula but their structural arrangement, or you can say that structural arrangement of the atoms are different, said to be as structural isomers, and the property is known as structural isomerism. Now move on to the second part of this particular class, where we will discuss about different types of isomers and their properties. Now start with the chain isomerism. Now let us try to understand what is the meaning of chain isomerism, or what are chain isomers. The organic compounds having similar molecular formula but having different arrangement of carbon chain are known as chain isomers, and the property is called chain isomerism. Now you can see that the definition already we have discussed, that same molecular formula but having different arrangement of the carbon chain are called chain isomers, and the property is called chain isomerism. Now in this segment we have considered some of the hydrocarbon which shows the chain isomers from the alkane family. The first one is butane, having the molecular formula C4H10, and butane can be written in two different ways, in a straight chain form and single branch chain form. It is normal butane, and the second one is isobutane. So these two forms are known as isomers of butane. There are no other forms are possible because their IPC name will be similar. It is very important to note that the IUPAC naming of the different isomers must be different. So in this case, the first one is normal butane or simply butane, and the second one is isobutane is the common name, and the IUPAC name is 2-methyl प्रोपेन. हम लोग ऑलरेडी डिस्कस कर चुके हैं नोमेनक्लेचर में. इट इज़ 2-methyl propane. So these two have different physical properties as well as some chemical properties. Now move on to the second example, and that is pentane. The molecular formula is C5H12. The molecular formula of pentane is C5H12. We can arrange like this: normal pentane, one branch, isopentane, there are two branch, and it is neopentane. And how we can understand normal iso and neopentane? This carbon, the central carbon has 4 degree, central carbon where the branch starts 3 degree, and in case of normal it is 1 degree. the carbon atom is attached with the one adjacent carbon atom, therefore it is 1 degree. Now the next one is 3 degree and 4 degree. So when the arrangement is 3 degree, we will have iso and the number of carbon atoms are 5, so it is isopentane, and in case of 4 degree carbon, it is considered as neopentane. I hope that all of you clearly understand this. By using the same method, we can write different isomers of hexane, but it is important to remember that normal isoneo is only used up to the 5 carbon atoms. So in case of hexane, there are different arrangements are possible. Only one thing you should keep in your mind, that the IUPAC name must be different. So it is simply hexane. This one 2,3 dimethyl butane. This is 2,2 dimethyl butane. It is 3 methyl pentane, and this one 2 methyl pentane. There are no other forms are possible. So the chain isomer or CI equal to 5. So hexane will show 5 different chain isomers. Now another very important point that you should keep in your mind, that in case of having functional group, you must remember one thing, that the position of functional group must be same under all conditions, only the arrangement of carbon chain will be different. So now try to understand by taking an example. Chain isomers of butanol. Chain isomers of butanol all simply indicates that the functional group is OH functional group. So the molecular formula of butanol is C4H9 OH. This simple arrangement N-butanol, then it is isobutyl alcohol. So there are two possible chain isomers of butanol. The IUPAC name you can easily write. The first one is butane 1-ol. This is butane 1-ol, and the second one numbering 2-methyl propane 1-ol. So there are two chain isomers for the butanol. In similar pattern, in case of having 5 carbon atoms, that is pentanol, the following arrangements are possible, and their IUPAC naming are mentioned for the pentanol. You can see that the position of functional group, that is the OH group, kept remain similar. There is no change in the position of functional group, but the arrangement of carbon chains are different. So in this, there are the common possibilities of having chain isomers of pentanol. We have already mentioned the first one, the second one, the third one, and this is the fourth one. Only one thing you must remember when you try to find out the isomers, you must know that the IUPAC naming of the given isomers must be different. Their molecular formula remain intact, but due to the different arrangement of the carbon chain, their IUPAC naming will be also different. Now move on to the another example. You can see butene. We are finding chain isomers of butene. Butene has a double bond and not a chain isomers. Yeah, it's a chain isomer. Sorry. Butene, the molecular formula is C4H8. So we can have the following isomers: one butene, two butene, one butene, and this is called normal butene, and this is isobutene, and its IPC name is 2-methyl prop 1 in. You can see that the position of the double bond always remain constant, and you can represent the above formula in the form of line diagram. Very simple. Now after this we have another very important type of isomers, and that is position isomers. Position isomers. You must remember only one thing: the molecular formula of the organic compounds will be different, but the position of functional group or double or triple bond not remain constant, that is their position gets changes. So let's start with the example. Butene, it is one butene, the double bond position at number 1, it is 2 butene. Similarly, in case of pentene, we have this is the first one pentene, and the second one is like this. You can write like this, and this is 2 pentene. The double bond position gets changes, it is 2 pentene. So these two are the position isomers of pentene. Now try to solve some more example. Here you can see that we have taken another example, and that is butanol. The molecular formula is C4H9OH. Sometime it is written like this: C4H10O, C4H10O. So first arrangement butane 1-ol and second butane 2-ol. The position of the functional group get changes. So these two are position isomers. Now after solving the position isomer, there are some you can solve for pentanol also. After solving position isomer, rest of the isomers with their examples, their definition will start in the next class. Till then, thank you. Goodbye.